Okay, in this presentation we're going to look at the 4 steps of hypothesis testing. So essentially what we're doing here is an introduction to hypothesis testing, just using and introducing the main sort of structure of hypothesis testing. Now, in undergraduate statistics, at the start what you might do in a lot of courses is use hypothesis testing or carry out hypothesis testing using critical values. So this 4-step process is relevant in that when using that approach, pen and paper exercises. There's a different approach when you're using p-values. It's similar, but there's a couple of things that are very different. Okay, so this is not using p-values, but that's a different approach, and it's also worth learning. So the first step is formally state null hypothesis and alternative hypothesis. Okay, so just actually write it out. Okay, just actually make a statement of what you're testing. Okay, so it's first off, what is useful there is to actually describe, and don't ever forget this bit. Just write a description of what your hypotheses are about. Okay, just don't rely on the mathematics. Actually write it out, spell it out, discuss what you're trying to find out or what you're trying to test. Okay, now where possible, because it doesn't apply to all tests, but where possible a mathematical notation would be useful as well. Okay, so if you're dealing with comparing two means, state mu1 equal to mu2 or mu1 not equal to mu2. I'll tell you what, I'll come back to that now in a second. So that is just actually sort of write it out, a sentence, okay, for both, and then a little mathematical description. Okay, so the next thing we're going to look at here is just actually what is commonly used to sort of format. The commonly used format for a hypothesis test. H0 with the subscript 0 usually is intended to denote the null hypothesis, and the alternative hypothesis is H1, but sometimes HA. I'm going to stick with H1, but also you could have HA. So let's just get rid of that. I'll just go back to, I prefer H1. It's just, well, I don't prefer it, it's just I'm using it, so I have to be consistent. Now, you can actually write in a little description of what the test is, depending on the question, but also what you might do is actually add in mathematical notation. So you would sort of say mu1, where that's the mean of population 1, is equal to mu2, or mu1 not equal to mu2. Okay, just write out something like that if you can. Not all exercises, not all types of hypothesis tests is it clear to write out a mathematical notation, but if you're dealing with stuff like sample means and sample means and sample proportions, then you probably should have some sort of written statement or mathematical statement of the null and alternative hypothesis. Now it takes a lot of practice to get the hang of that, but after a while it should come to you. Now usually, just as a remark, the null hypothesis is usually some sort of statement of absence or negation or equality. Equality being an absence of difference or no difference. Okay, so it's always a sort of good idea just to remember that. So no difference. Okay, so the null hypothesis is usually that sort of negative quality. It has a negative quality or an absence quality. Okay, that's a bit of a sort of far-reaching statement, and sometimes it might not actually help us, particularly with some hypothesis tests that might not be as illuminating as one would like to think. But in general, absence or negation, okay, and our equality, where equality is no difference. All right. Now, the second step is compute the test statistic. Okay. Now, for most college courses, what you're going to look at here is the sample mean and sample proportions. Okay. So it's a sort of based up of 3 components here. So the first component is the observed value or the sample estimate, or essentially actually point estimate. Okay. Is another way of stating that, the point estimate. Now the expected value under the null hypothesis, there's H0, the null hypothesis. Okay, so what value do we expect under the null hypothesis? Okay, and then over the standard error. Okay, so observed value, or also known as the point estimate, minus the expected value under the null hypothesis. Quite often actually you'll find that will be oops, that the expected value under the null hypothesis will be just 0, okay, but that's what it is. And then finally the standard error. Okay, the standard error is usually given to you in a formula sheet. Just watch out for it, because take a bit of a time to practice calculating standard errors, and just remember you have the right one for each scenario. Okay. Now, so that's the test statistic. Now, there's a couple. It doesn't apply to 100% of tests. For example, in my courses I use a Dixon test just to sort of introduce hypothesis testing. This would not apply here. Okay, it's a very simplistic way of calculating the test statistics. So just watch out for that. It doesn't apply in each and every case. It usually applies in the things like sample mean or sample standard deviation or pair t-test or something like that. So the next step, okay, scrolling down, is determine the critical value. Okay, and this is dependent on a specific parameter, or a specific measurement, or not a measurement, specific value that you set, alpha. Okay, so that's alpha, the Greek letter alpha. Okay, and that is the significance level. Okay, now I'm not going to really get into that here, because this is sort of related to type 1 and type 2 error, which is probably something you're going to sort of see later after this. Okay, so but usually for undergraduate statistics it's set at 5%, sometimes 1%. So 5%, also known as 0.05. Okay, so they're 5% and 0.05 are essentially the same thing. Now what you do here is you look up statistical tables. Okay, so that's essentially they're usually tabulated in some sort of tables that are given to you in the exam. Okay, for example, in my own classes I would use Murdoch-Barnes. Okay, but there's other tables like the Cambridge tables and so on. Now, the critical value, it can depend on other things, depending on what type of test you're doing as well. Okay, so it could depend on the sample size. It can depend on a thing called degrees of freedom, and it also can depend on what type of test you're doing. Is it a one-tailed test or two-tailed test? Okay, so that's probably best sort of when you do some more examples on that, like that might be the right time to sort of follow it up. Now, finally, this is a little decision rule. Step 4. Okay, so is the test statistic, that being capital TS test statistic, and the absolute value of the test statistic, so just in case you get negative numbers, is it greater than the critical value? That's what we're going to ask. So if yes, we reject the null hypothesis. Okay, so my pen's got weird there. So we reject the null hypothesis, reject null hypothesis, etc. If no, this one's important now, we fail to reject the null hypothesis. Okay, so that's the wording there is really important. We fail to reject the null hypothesis. Okay, because really hypothesis test is not really about what is true or what is false. Okay, it's more a statement about the strength of evidence. Do we have enough evidence to contradict the null hypothesis is really what we're doing. What's that? It's a bit of a crude way of explaining it, but it's better than saying this is true or this is false. Hypothesis testing is not a proof. Okay, it's not a mathematical proof. It's not a definitive statement about what is true or what is false. Okay, it's just essentially more about the strength of evidence. So just to sort of a good thing to sort of look at, just to sort of make sure that it is clear in your mind, is just the idea of a type 1 and type 2 error. Essentially what these are type 1 and type 2 error. What happens when you get it wrong, essentially. Okay, so that's well worth knowing, type 1 and type 2 error.